Okay, so today we are going to look at angle pairs created by parallel lines cut by a transversal. So you should have 4 different white pages and then 1 blue page. So you should have page number 14, angle pairs created by parallel lines cut by a transversal. Number 15, which goes along with the blue page. So then you should have a blue page with 12 different tabs that you cut out. And then, so I have this blue portion across the top. So where that is, you're folding. So you're only gluing this little part here down when we get to that spot at these pieces here. Then you should have pages 16 and 17, which are where we're going to start to solve problems. So 14 and 15 are mostly just like the visualizations and the vocab. And then page 16 and 17 are where we will solve. And then we will talk about the assignment. So for this, we're going to look at some vocabulary. So on a problem where I have parallel lines cut by a transversal, the first thing we're going to talk about is what is a transversal. So a transversal is a line that crosses parallel lines to create pairs of congruent and supplementary angles. So visually in the diagram, the transversal is the single line, the one that's by itself. So that's our transversal in this diagram. Remember that it's going to create 2 different types. It's going to create congruent angles. So congruent angles have the same measure. The symbol for congruence is the equal sign with the tilde squiggly at the top. And then the other type of angle that it creates is supplementary angles. So remember that supplementary angles add up to 180. Remember that the clue to remember that is that the S, I can make the S into a 180 versus complementary started with the C, and I can turn that into a 90. So these angle pairs are going to use words like interior and exterior. So visually, you remember that when I'm talking about interior and exterior, it has to do with it being interior, exterior to the parallel lines. So the exterior angles are outside parallel lines. They're only touching one line. The way that I kind of think about it is that interior is between. Okay, so when I have angles that are interior to the parallel lines, they are between them. So again, exterior and interior are in reference to those 2 parallel lines on our diagram. So we have a few different types of angle pairs that we're going to review in this lesson. The first type of angle pair are angles that are on the same side of the transversal and on the same side of the parallel lines. These angles are in the same corner and are congruent. So these angles are what we call corresponding angles. So an example of corresponding angles would be this angle is in the top left on this parallel line, and then this angle would be on the top left of that parallel line. So that would be one pair of corresponding angles. There's actually 4 different pairs of corresponding angles on any given diagram like this. These types of angles are congruent angles. So if I have a pair of corresponding angles, that tells me that they have the same measure. The next type of angle that we're going to talk about are angles that are on opposite sides of the transversal and inside the 2 parallel lines. Okay, so they're on opposite sides of the transversal, so one's on the left and one's on the right. But they're inside the parallel lines. So that means that they're going to be here and here. And so these angles are called alternate. That's this opposite sides of the transversal part. And then the inside the 2 parallel lines tells us that they're alternate interior angles. So alternate interior angles are on opposite sides of the transversal inside the two parallel lines. There's only two pairs of those, so this, oops, I'm going to put dots. This and this would be the other pair of alternate interior angles. So the two angles where I have those dots are also alternate interior. Then I have angles that are on the opposite sides of the transversal again. So that's that alternate word. So opposite sides of the transversal is telling me that they're alternate. But this time they're outside of the parallel lines. So when they're alternate and outside the parallel lines, they're alternate exterior angles. Okay. So alternate exterior angles would be this angle. So it's on the right side of the transversal on the outside of the parallel. So if I go to the outside, it has to be on the other side. So it's on the left. So that would be a pair of alternate exterior angles. These angles, just like the alternate interior, are congruent. Okay, so another pair would be the ones right next to it. So that would, the two dots would show you the other pair of alternate exterior angles. And then, so the way that we use alternate for opposite sides, we don't have a special word. We use the word that they're using to describe it. If it's on the same side of the transversal, we call those same side. Very creative. So these are same side. And then inside the parallel lines, we remember we said is interior. So same side interior angles are supplementary. So what that means is that they do not, they are not marked the same. They are two different angles that add together. So same side interior angles would be this angle and this angle. So I'm marking one. Ooh, I need to zoom in so I can do that better. So the top, the one on the top left and the one on the bottom left, those are same side interior. Similarly, I can do the same thing on the other side. So if I had this, let's use, so this with this, I'm going to use a dot and an X to show that they're not congruent. So those two angles would be also same side interior. And then the difference here between what we just did and what we're doing next is, boy, use green. So we have another same side of the transversal, so same side angles that are outside the parallel lines. So they are exterior angles. So same side exterior angles are also supplementary. So the way that I remember this, and hopefully it'll help you, is that if it has that, if it starts with that S, that those angles are supplementary. So same side, whether it's interior or exterior, if they're on the same side of the transversal, they're going to be supplementary angles. So same side exterior angles would be, so this angle and this one, so the two on the right, and then or the on the left if I do a dot and an X, just to indicate that they are not actually congruent angles. So those two would have to add to 180. Finally, this is what we talked about before, angles that are across from each other and are formed by intersecting lines. So these are our friends, the vertical angles. So a pair of vertical angles would be like these two angles or these two angles, right? There are lots of pairs of vertical angles in any given diagram, 4 pairs of them. So the ones that we have a lot of are the vertical angles and the corresponding angles. So there are 4 pairs of those versus there are only 2 pairs of the rest, which is why I kind of showed you all of them for the rest, but only pieces of them for corresponding. So what we're doing on the next page is we are going to be pasting on the little flats. So if I'm looking at these, let's start with just whether they're congruent or supplementary, and then we can find the an angle that represents it. Okay, so corresponding angles are angles that are congruent. Okay, so we can see over here that corresponding angles look like this. There's different pairs of them, but we know that they are all congruent. And so what we're going to do is look for the blue paper that corresponds to that. And so my suggestion is that you cut them all out, but you lay them in order. That's what I've done here. So if you want to pause the video so that students can have the time to do that, that might be a good idea. Or you can kind of cut as you go. So if the angles are corresponding, they're in the same location. So for example, this first tab is actually corresponding because I have one in the top left on this parallel line, and then I have another one in the top left on the bottom parallel line. So this picture is an example of corresponding angles. So you're gonna fold this on that dotted line and glue where the blue is attached to where it says glue flap, so that you should be able to flip it up and down, just because of the nature of what I did. This might, I'm gonna have to bring it to the front. There we go. So then that's going to be the flap there, so that you can kind of quiz yourself and say, okay, this is which vocab word, is how you should use this page to quiz yourself on the visual. Same side exterior angles. Remember, my hint is that if it starts with that S, that the relationship also starts with an S. And so if I have same side exterior angles, that means that these angles are supplementary. Oh my gosh, supplementary. I might abbreviate after this. Oh, it looks like this isn't gonna work. So every time I write, it brings that to the forefront. So same side exterior angles. So I'm looking for angles that are on the same side of the transversal and on exterior angles. So notice that this one, I have exterior angles. The angles are outside the parallel lines, but they're on alternate or opposite sides of the transversal. So that won't be same side exterior. However, this one here is. So this is flipped sideways, but it's still exterior. So if I look at it with the parallel, it's not between the two parallel lines, it's outside them, and it's on the same side of the transversal. So this picture is a same side exterior angle. So you want to glue that flap there. Vertical angles, we said, are congruent. I'm going to start to write that. And again, my words are just coming up onto the front. You shouldn't have your word written on the front. It's just the nature of what I'm using to do the video. So vertical angles share a vertex. And I actually see two diagrams of those. So if I look, they kind of create this hourglass shape. So notice that this spot is a vertical angle. Since the one right below it is also a vertical angle, let's find the other side piece that says vertical. So angles are congruent. And so that vertical angle, I'm going to glue to that one. Okay, so we've got 4 of these 12 done. Again, you should be gluing it so that it's a flap and you can visually quiz yourself on, okay, what does this look like? Check the vocab, identify whether it's congruent or supplementary. Our next one is same side interior. Remember, as soon as we see that word same side, we should think supplementary. And I'm gonna abbreviate this one just because I don't wanna have to try to fit it every time. So if you write large, you might. So I'm just gonna write supplement to abbreviate. So same side interior. So if we look at what our same side exterior, remember they're on the same side of the transversal, but they're outside the parallel. So these are going to be between the parallel lines on the same side of the transversal. So this one, if we look at it, they're on opposite sides of the transversal, so it's not that. This one, is the opposite of what we just looked at, right? So notice that they are on the same side of our transversal. Both of them are above our transversal while they're between the two parallel lines. So that picture is same side interior. Then we have alternate interior. So remember, alternate interior is where they're between the parallel lines still, but now they're going to be on alternating sides. So it would be like where one of them's going to move over here. So this black one would move there if I was using the same diagram. So these two angles are congruent. So alternate interior. So we're looking at opposite sides of the transversal between the parallel. And actually notice that these two are those. So this is one pair and this is another pair. So again, it doesn't matter which one we use. Let's just paste one down and then we can find the other that has the same word. So we have, and that other alternate interior angle is also going to be congruent. And so we can paste the picture down in that bottom right corner. So that diagram is going to glue in with, again, it's another alternate interior angles. So remember that alternate interior angles are between the parallel lines. So if I look at the next one from where we're building on, the same side interior angles, they're going to be between the parallel lines. But both angles are going to be on the same side of the transversal. And so remember, same side is always supplementary. So I'm just going to abbreviate again. So I have exterior angles here. These are interior angles, and they're on the same side of the transversal. So that's the piece that we're going to glue down for same side interior. And again, remember the idea here is that you can kind of quiz yourself with what the vocab is. So looking at the diagrams and identifying which type of angle pair you have on this once we're finished with all of this and it's glued in your notebook. So then for our next two, actually, if we look at those, they're alternate and exterior angles. Alternate exterior angles are always congruent. So I'm going to fill in congruent for both of those. And so looking at the top diagram that I have, I already talked about, these are exterior angles, so they're outside of the parallel lines. And notice that it's on alternate sides of that transversal. So I know that that is an alternate exterior. So this flap is going to get glued on in that spot. And the last one that is exterior and alternating, notice this is, these are not, one's interior, one's exterior, so that's going to be something different. Here we have two exterior, but they're on the same side of our transversal. And so that means that this one on the bottom right is our alternate exterior. So you're going to glue that diagram over alternate exterior. Our last two are corresponding and same side exterior. So the same side exterior angles are supplementary angles. So whenever, again, we have that same side, that's when we identify things as being supplementary. And so looking at this, remember we talked about these, it was one interior, one exterior, so those are not same side exterior. And then this last one, notice they're on the outside of the two parallel lines, which makes them exterior, and they're each on the left side of the transversal, so that's the same side piece. And finally, that one where we have one interior, one exterior, that's corresponding, right? They're both on the bottom right of two intersecting lines, right? These lines are intersecting, it's crossing at the bottom right. These lines are intersecting, it's at the angle on the bottom right. And so corresponding angles are always congruent. And so we're going to glue that flap there. So this page gives you each of the vocab with a little bit of a visual on the left page, on page 14. And then on page 15, you have these flaps so that you can quiz yourself and get a practice with that vocab, and then those words that are showing up on top of mine, remember, are underneath yours. So if you guys need to pause this video so that you can make sure that everything's laid out and everybody's glued down before we move on, that might be a good idea right now. On pages 16 and 17, we are going to apply these theorems. So you should have these already cut apart. In page 16, we have a little bit more basic of properties where it's just x is the angle. So we're identifying that angle measure, versus on the right-hand side on page 17, we've got where the variable is embedded in the expression for the angle. And so we have to solve for the variable and then plug it in to get the angle measures. So let's start on page 16. So angle pairs created by parallel lines cut by a transversal. For each set of angles, we're naming the angle pair and finding the missing measurement. So visually what we're looking at is which of these is it? So it might be a good idea to have one of these two pages to flip back to. So for the first one, notice that I have one interior angle, 68 degrees, and one exterior angle, but they are both in the same location. So that means that these angles are corresponding. We gotta kind of squeeze in here. This is a little bit small to write on. Corresponding angles are congruent angles. I'm just going to use the symbol of congruent for brevity here. So these angles are congruent. And what that means is that they have the same measure. So if the angle is 68 degrees and its corresponding angle is x, that means x must equal 68. Notice I don't have to put the degree there because the degree is already there next to the x for that angle. For number 2, we have two interior angles. So I can see that they are interior angles. They both lie on the same side of the transversal. So the transversal is here. They're both below the transversal. So that means that these are same side interior angles. And just because there's not much space, I'm going to abbreviate interior. INT. Same side, any kind of angles are supplementary, which means that in order to find x, what I'm going to do is I'm going to subtract 180 degrees minus 134 degrees to find the measure of x. So anytime I have supplementary angles, I'm doing 180 minus the angle that I was given. So that means that x is 46 because that angle is labeled as x degrees. For number 3, they both touch the same parallel line. When that happens and they're straight across from each other, these are vertical angles. Remember that vertical angles are one of our pairs of congruent angles. So these angles are congruent, which means that if that first angle is 120 degrees, that x is also 120. So the bottom left, our last question on this side, we have this diagram with 101. Notice that 101 is an interior angle. It's inside the two parallel lines, as is x. So these are interior. If we compare to where it is on the transversal, they're on opposite sides of the transversal. So these are alternate interior angles. So again, I'm going to abbreviate interior as INT. Alternate interior angles or alternate exterior angles are all congruent angles. So these two angles are congruent, which means that if this angle is 101, x is also 101. So we're halfway done with that page. For number 5, our two angles are exterior angles. I can see that they are not on the outside of the parallel lines. So then I'm thinking about the transversal next. So looking at the transversal, they're both below the transversal. So that means that they are same side. And again, for space, instead of writing out exterior, I'm going to use the abbreviation EXT. So INT for interior, EXT for exterior. Same side exterior angles and same side interior angles are all supplementary. So that means that in order to find the measure of x, what I'm going to do is subtract 180 minus 77. So if we do that, 180 minus 77 means that x is 103. If we're looking at the angles in problem 6, again, we're first checking inside or outside the parallel lines. So looking at the parallel lines, these are interior angles. And if I compare next to the transversal, these angles are on all opposite sides of the transversal. So that means that these are alternate interior angles. So two alternate interior angles are always congruent angles. Which means that if this angle is 106, x is also 106. For number 7, we have two angles that are in between the two parallel lines. So that means that they are interior angles. And then if I compare that on the or with the transversal, notice they're both on the left side of the transversal. And so that means that they are same side interior angles. Okay, so same side interior angles are supplementary angles. Which means that in order to find the value of x, we have to subtract from 180. And so in this case, we're doing 180 minus the 74 of the other angle, which means that x is 106. For the last problem on this page, we're looking at exterior angles. So those angles are on the outside of the two parallel lines. And then if I look at the transversal, one's on the top and one's on the bottom. So that means that these are alternate exterior. Alternate exterior angles are angles that are congruent. And so that means that x and 142 have the same value. So x is equal to 142. On page 2, we had simple problems where we know an angle measure and we want to find another based on those angle pair relationships that we have on page 14 and 15. What we're going to look at next is just more complicated problems where I can't just do a simple, oh, it's this number, or I'm just going to subtract this other number from 180. And so I am still using the idea that they're congruent or supplementary, but I'm going to have to solve an equation to get those answers. So if I look at number 1, my parallel lines are the horizontal lines. My two angles are inside those parallel lines. So that means I have interior angles. If I look at the transversal, they're both on the right side of the transversal. So that means that they are same side interior angles. And so same side interior angles are our supplementary angles, which means that I'm going to take and add the two angles together and set that equal to 180. So when I have supplementary angles, I add the two angles together. So 3x and 6x. and I'm going to set that equal to 180. So from there, what I'm gonna do is I'm gonna simplify this. So 3x plus 6x is 9x. If 9x equals 180, and I divide both sides by 9, that tells us that x equals 20. So 180 divided by 9 is 20. To find the angle measurements, remember that means that we have to plug 20 in to each value. So 3 times 20 gives us an angle measure. 20 gives us an angle measure of 60 degrees. So one angle is 60. And then the other angle is 6 times 20. So 6 times 20. 6 times 12. So 6 times 20 is 120 degrees. So in the diagram, we have same side interior angles. Those angles are supplementary angles, which means I'm adding the two measures together and setting it equal to 180. For the next diagram, our parallel lines are the vertical lines. And so if we look at where our angles are in comparison to those parallel lines, they're both exterior angles. They're on the outside. So I know this is something exterior. If I look at the transversal has one on top and one on bottom. So that means that these are alternate exterior angles. I have to do that a little crooked because there's not much space. Alternate exterior angles are congruent angles. And so when angles are congruent, that means that I'm going to take them and set them equal to 1. So that means that I have 7x minus 12 is equal to 3x plus 28. And I any like terms, just copy this equation back down. I'm going to make sure it works and do the first step in the box. So in the first problem, we had a supplementary relationship. And so our equation was 2x's equal to 180. So we had like terms we could combine, is why I just cut there. Here I didn't have like terms. So that means that I need to move all the variables to one side and move all the numbers, the constants, to the other. And so evaluating, I'm looking at 7x and 3x. Since 3x is smaller, I'm going to subtract 3x from both sides. And the 3x, that means I move the 12 as well, so add to both sides. My variables are all left and constants. So doing that, we have 7x minus 3x, so there's 4x equals 28 plus 12, so 8 plus 2 is 10, and that means we have 40. So then this equation tells us that if I divide by 4, x is 10. And so what I want to do is take 10 and plug it into each of these angles. So if I set it times 10 minus 12, that's going to give us 70 minus 12. So our angle then is 58 degrees. Okay, so 70 minus 12 is 58. And then since they're congruent, I know that that means my other answer should be 58. So a good way to make sure that your work is correct is by actually plugging in the two answers. So 3 times 10 plus 28 should give us 58 is 58. So we know that 8 times 10 for x is correct by checking those, right? So technically we know they're congruent, so we only have to do one, but it's a good way to check your work from the solving portion for x. Okay, so we have two more. So for number 3, we have 3x plus 77 on the outside of the two horizontal parallel lines, as well as 4x plus 54 on the outside of the two parallel lines that are horizontal. So that means that these are exterior angles. If we look at where the transversal is, they're all on the right-hand side. So that means that these are same side exterior angles. And anything that's same side, whether it's interior or exterior, remember, are supplementary angles. which means that I'm going to take them and add them and set equal to 180. So I have 3x plus 77 plus 4x plus 54. And that's equal to 180. And so what I'm going to do again in this step is combine my like terms as I write it over here to show my work. So 3x plus 4x is going to give us 7x. And then 77 plus 54 is 131. So 7x plus 131 is equal to 180. So as I solve this, I need to get all of the constants to the right-hand side. So I'm going to from 180, which leaves us with 49. And so that leaves us the equation 7x equals 9. If I divide both by 7, is that the value for x of 6. And so what we need to do is plug these in. And again, since they were supplementary, I should get two numbers that add to 180. So a way to check that my answer is correct is if I add those two numbers together. And so I'm going to plug 7 in for both of these x's. I'm just going to write the 7's down before I change colors. So I have 3x plus 77. So I have 3 times 7 is 21. 21 plus 77 is going to be 98. So 98 degrees for that first one when x equals 7. For the second angle, I have 4 times x plus 8 is 28, and 28 plus 54 is 82. And so remember, one thing that we want to check is if I add 98 plus 82, do I get 180? And so that does work. So 8 plus 2 is 10. If I carry the 10 over, I got 9 plus 1 plus 8 is 18. So for our final diagram, we've got vertical parallel lines. Notice that the 9x plus 8 is an interior angle, and the 4x plus 18 is an exterior angle. So when that happens, we either have vertical angles or we have corresponding angles. So vertical angles actually touch the same parallel lines. Since these are touching different, these are corresponding angles. Corresponding angles are congruent angles. So that means that my equation is going to be where I'm setting these two angles equal to one another. So I have 9x plus 8 equals 4x plus 18. I do not have any like terms on either side of my equation. So I'm just going to rewrite the equation as is to show my work. So this one is like inverted here, where we need to move all the variables to one side, right? The constants to the other. So what we're going to do is move, so I'm 9x and 4x. Since 4 is smaller, I'm going to subtract 4x from both sides. And that's going to eliminate the variable. Since I'm moving the variable to the left, from both sides. So when I do that, I have a term e to x minus 4x. 5 equals 18 minus 10. So then if we double 5, 10 by 5 is 2. So the value. So for each of these pages, we're going to have problems on the assignment for today. So today you're working on page 14A. So they're each mazes. For the front, there's really no work happening. So if I look at the diagram on the front, I have two options. It's either going to be that this is alternate exterior angles or vertical angles. So vertical angles have the same vertex. So that means this is alternate exterior angles. So you're either shading this in with a pencil or using a highlighter. So that means you're doing this diagram next. And so looking at this diagram, you're identifying Is it alternate interior, same side interior, vertical, or alternate exterior? So remember that as you go through, you should end up in this box here. So you're either end up with vertical angles here or corresponding angles here. And then that's just vocab. For the next one, you've got like what we did on page 16, where you have, I'm just making sure it's 16, page 16, yes. So it's like what you did on page 16, where you have the angles and you just have to find the value for X. So in this one, for example, on the first problem, we're starting here. So ultimately, if you look at our options, it's either that X is 80, so either these are congruent, or X is 100, these are supplementary. And so what we're looking at is they're both between the parallel lines, so they're interior angles, and they're on opposite sides of the transversal. So that means these are alternate interior angles are congruent. So it's going to be 80 for this one. So then your problem that you'll do next is this one with the 100 and the X. And so notice that this one isn't necessarily a relationship that we've seen. So this isn't corresponding because this one would be corresponding with this. So that angle would be 110 if we think about it as being corresponding. And so then for X, it's making a linear pair now with the 110. So my options here are that it's 60, that it's 110, or that it's 70. And so if I have a linear pair now, that means it has to add to 180. So my answer is going to be whichever number makes plus 110 creates 180. And then the back of the page is like what we did on the last set of problems. And so what you're doing is we're starting here, but you're showing your work down at the bottom. So you do need to have this filled in to get any points for this assignment. And so for the first box, we have vertical angles. And so their share of vertex. And we have to set those equal to one another. So in that first box, you're going to do 3x minus 1 equals x plus 5, and solve that to find the value for x. Once you've solved it, then you're highlighting the arrow and then the next box to continue.